So welcome back. The last video we talked about intercept coefficient. We talked about what would be the variance if the errors are normal, which usually you can assume by central limit theorem. Then you have a normal distribution of beta, also alpha, right? Alpha hat. Then we can do hypothesis testing, and we can do interval estimation. Right, the same idea here, right? We can extend it to the slope coefficient, right? And again, here we're trying to solve the slope, the variance of the slope, okay, coefficient will be much simpler expression, will be the sigma square over the sum of x, okay, sum square of x, okay. And if the error are normal distributed, then the beta hat will be normal distributed with mean beta, because again, coming from the unbiasedness of beta hat, okay, is mean of the beta hat is beta, and the variance follow the sigma beta hat, okay. That's why we're trying to prove this one, okay. This need not, okay. And then we want to see, okay, standard error is defined as replace the sigma by s, and denominator will take the square root, right? Because that's called standard error. So we're trying to show the first bullet point, right? Why this is true. A little bit technical, so bear with me. But just one slide only. This is easy. So again, assume SX6 is shorthand for sum of square on x, and beta hat will be the variance of beta hat, right? Will be variance of the fraction, right? Will be sum of square of x and y, and sum of square x, right? And remember, x are constant, right? In this model, so that's why this can be taken out and put square to it. Okay. And because why you can also do that, because y the epsilon, right? I and j are uncorrelated. The fourth item in the assumption, right? They're uncorrelated across observation. So that's why the summation can be taken out for each one, and that's why only square in this way. Okay, so this is why you can take square in this way. Okay, and when it's square, this sx is also square. Okay, and remember the variance of yi minus y bar, okay, and y bar, okay, will be alpha plus beta and blah blah blah, right? And alpha and beta are not changed, x are constant, so only epsilon is the changing part here, right? So that is only left by sigma, okay, that's why it's sigma square. Okay, or again, yi minus y bar is this is only alpha plus beta x bar, so this constant term, so that's why yi is only epsilon, okay, only epsilon left. So that's why it's sigma square. And then sigma square to be taken out. This is sxx, right? So that's why sxx over sxx square, so it's sxx and sigma square. Okay, so this is why we explain this. Again, we can do hypothesis testing. We usually try to see whether the coefficients are 0 or in general equal to some number b. And the same idea as slope, and in the intercept, we take beta hat minus b over the standard error of beta hat will be follow t distribution with degree of freedom n minus 2. Okay, and the point estimate will be same as the beta hat because it's unbiased, right? The interval will be t times the standard error, right? So that's why we have the interval estimate will be the point estimate plus minus t value times the standard error. Okay, that's the end for this part.